In this demonstration, I'll show you how to deploy a web application to Amazon EC2. Our web application will consist of some static images, and we'll be using Amazon S3 to host our static images. I'm going to use ASP.NET Core version 3.1 to build my web application. So let's get started. First, let's navigate to our browser and let's open up the aws.amazon.com webpage. Let's go to Account and we'll choose AWS Management Console. Here, I need to provide my account ID or the account alias, which I've already provided. And I'm going to sign in using my username and my password. This user Manoj Nair is an IAM administrator. So he has all the required permissions to work with Amazon EC2 and S3 in this case. So let's go to EC2. And under running instances, you'll see that I already have one instance up and running. Let's launch one more. For the purpose of this demonstration, I'm going to launch an Amazon Linux 2 instance. So we'll select that real quick. Now I'm going to take advantage of the free tier and use T2 Micro, which offers me one virtual CPU and 1 GB of RAM. So we'll choose a T2 Micro instance. Under configure instance details, we just want to launch one instance. And we're going to launch this instance in the default VPC. The default VPC comes with 3 subnets, one in each availability zone. And we really don't care which availability zone this particular EC2 instance resides in. You will notice that it will also get a public IP address, which is what we want so that we can connect to it and we can serve a web application from that particular IP. The only property of interest for me in this section is the user data. Here, I'm going to paste the bash script that will install the .NET Core SDK version 3.1 on this Linux instance. Now, of course, I could launch the instance, SSH to it, and then install the .NET Core SDK. That's totally fine. But user data allows me to provide a bash script here, and this will be executed with full sudo privileges, which is full administrative privileges. And this is great for making sure that you can bootstrap your EC2 instances with all the required software. So I'm going to paste the bash script here, and this bash script is basically going ahead and using RPM and then installing the .NET Core SDK version 3.1. Let's click on Add Storage. 8 GB is just fine for this demonstration. I'll add a tag. Let's give it a name. And for the value, I'll choose let's.net version 3.1. All right. So we have provided the name and the value. Let's go ahead and configure security group. I do have an existing security group. Remember, security groups are stateful firewalls. And because they are stateful firewalls, the return traffic is also allowed. I'm going to bring this down and select one of the security groups that I already have, which is this EURSGLIN. And if I just make this a little bit on the top, you will see that this basically allows port number 80 and port number 22 for all IP addresses. Now, this is again a bad practice. Allowing all IP addresses to make an SSH connection on port number 22 is not considered a good practice, but this is just a demonstration, so we will be okay with it. We definitely need to allow port number 80 so that we can connect to our HTTP application. Let's click on Review and Launch. This will give you a brief summary of all the options that we have chosen so far. Let me click on Launch. It'll ask me to select a key pair. I already have a key pair here in the Sydney region. So I'm going to acknowledge that I have access to the key pair so that I can SSH to this particular box. Let's go ahead and launch instance. And we have successfully launched our EC2 instance. Here it's currently in the pending state. Let me refresh. And we'll give it a few seconds. And once it gets into the running state, we'll try to connect to it to see if it's up and running. All right, our EC2 instance is now in the running state. Let me refresh this real quick. I could right-click on the EC2 instance, go to Instance Settings, and choose this option here, Get Instance Screenshot. And here you can see that I'm getting a screenshot of the instance console, which is really cool. And I can see that this instance is waiting for me to log in. This is absolutely amazing. I'm going to close this. And now that we have our EC2 instance up and running, it's time for us to build the web application and deploy it to this EC2 instance. So let me open up JetBrains Rider. You could use any IDE of your choice, but I'll be using JetBrains Rider. And I'm going to create a new solution. We'll choose a web application, ASP.NET Core web application, and I'm going to call this Let's.NET. For lack of anything interesting. It's going to be based on the 3.1201 SDK. It's going to be a simple web app, and I'm going to go ahead and store this inside my E directory under Projects, Visual Studio, and I'm going to click on Open here. Let's go ahead and click on Create. This will bootstrap the solution and will give me a project so that I can start working on my application. All right, so my application has successfully launched and I need to go to my application here. And let's quickly run this application to see if we are able to see the default page. It's going to build my application and we will be able to launch the browser. And as you can see, it connects to localhost port 5001 and displays a very simple ASP.NET Core web application. Now, again, I'm not going to build something which is rocket science here. We're just going to build a simple web application with a static content. So let me navigate back to my application and let's stop this. And what I'm going to do is inside pages, I will go to the index.cshtml and I'm going to display an image here. Now, first thing I'm going to do is right inside this div, let's put in an image and I need the source attribute of that image. So let me actually bring an image to this directory. So let's go to documents or pictures. Let's go to our save pictures. I'm going to copy this AWS training logo. Let's copy that. Let's go to our E drive where we have created this project. And I'm going to paste this inside this www root directory. That's where we store our CSS, JavaScript, and our images. So I'm going to store my AWS train logo in this particular folder. Let's go back to our application. And as you can see, I can now bring in my image and I'll specify an alternative text here. So this is the AWS logo. Beautiful. All right. Now that I have my image ready, let me actually bring this like this. Now that I have my image ready, let's also add a few dynamic information here. For example, I might be interested to check the name of this machine. So I want to go and pull in the environment variable called machine name. So that's the name of the machine. So I could say the application is running on this machine. Let's go ahead and rerun our application. It's going to open up the browser on port number 5001. And as you can see, it says that the application is running on Eureka PS-01. This Eureka PS-01 turns out to be my host name. So it picks up my host name and says that the application is running on Eureka PS-01. And you can also see the static image, which is the AWS Training and Certification logo. BEA, beautiful, brilliant. Now it's time for me to package this up and send it to the EC2 instance. So first thing first, let's navigate to our application and I'm going to stop this. And I'm going to use JetBrains Rider's SSH capability to connect to that EC2 instance. So let's first navigate to our AWS Management Console. And I need the IP address here, the public IP, so that I can connect to it. In JetBrains Rider, I could go to Tools and click on Start SSH Session. I need to provide my host name here. So that's going to be the IP address. The username is going to be EC2-user. We're going to use the key pair and I need to provide my key pair here. So let's go to Documents, AWS key pairs, and I'll select the Manoj Nair Sydney key pair. Brilliant. Let's click on OK. I'll say yes. And as you can see down below here, I've successfully connected to my EC2 instance. Let me clear the screen here. And if I run .NET --version, it displays the version 3.1.201. That's because if you remember in the user data field, we gave it a bash script to install the .NET Core version 3.1 on this particular box. Also, I am going to create a directory here. So let's say mkdir, and I'm going to call this let's.net for lack of anything interesting. If I spell that correctly, there we go. So now I have a directory called let's.net here. Let me now go to my application, and I'm going to create a new configuration here. So I'm going to edit configuration. I'm going to add a new configuration, and we will choose the ability to publish this to a custom server. So I'm going to select that option, and I'm going to name this as deploy to EC2. We will select the project as let's.net, and on the remote server, we don't have any remote server to push this application to. So I'm going to click on this ellipsis here. We'll add an SFTP box. Again, we'll call this my EC2 instance. And here I need to provide the host name again. So let me paste in the IP address. Username happens to be EC2-user. We are going to use key pair, and I'm going to browse to that key pair again. So documents, AWS key pairs, will choose Manoj Nair set.pem file, and I'm going to test my connection. And you can see that we've successfully connected to the EC2 instance. Now let me auto detect the root path, and here let's navigate to our folder on that remote server. We'll navigate to the folder that we just created. So that's under home, EC2 user, let's.net, and I'll click on OK. And I'm going to click on save. So we've created the configuration that allows us to push our web application to that EC2 instance. So I'm going to click on OK. Great. Now there's one small thing that I need to do in my application. If I navigate to program.cs, currently this web application is running on port number 5000. I want this application to run and respond on port number 80. To do so, I need to go and take advantage of this web builder's use Kestrel extension method. So let's go back here, and I'm going to say web builder dot use Kestrel. I'll provide it and Kestrel server options, and I'm going to say options dot listen on IP address dot any and on port number 80. Okay, I'm going to make sure I put in the missing semicolon here. And with that thing done, it's time for us to package this and push it to the EC2 instance. The configuration is set to deploy to EC2. So let's go ahead and click on run deploy to EC2. This will go build the package for me, publish the package for me. And if everything goes well, it should connect to this particular server and push all my artifacts to that let's.net directory. As you can see, the deployment is successfully completed. If I go back to my terminal, and if I clear my screen here, and let's navigate to the let's.net directory. If I do a quick ls, you'll see all the files are available here. Now, I'm going to do a quick sudo .net let's.net.dll. This will start my application, and my application is running on port number 80. So let's navigate to the browser. I'll copy this IP address. Let's go to a new tab, Control V to paste the IP address, and hit enter. And there we go. We have our web application successfully running on that EC2 instance. Awesome. Now, right now, this static image here is currently being run from an EBS volume that is attached to the EC2 instance. So let's say you have multiple users connected to this web application. It's basically you're going to use the bandwidth that's offered by T2 Micro to serve the static content. We just now learned about S3, where S3 is an object store designed for internet-based object store data. So we're going to use S3 to host the static website. So let me navigate to the AWS Management Console. Let's go to Services, and let's go to S3 real quick. Once we are on the S3 console, let's create a resource called a bucket. Now, the bucket name has to be globally unique. So let's call this let's.net to see if that is available. It's going to be in my Sydney region. I'm going to make sure that I enable bucket settings for block public access. This will make sure that I don't make any of my objects public. Ideally, since I really wanted to make that static image public, I could go ahead and uncheck that. But I just want to adhere to best practices. I'm going to go ahead and create that bucket real quick. All right. So it looks like that bucket was created. So if I scroll down, I do see this bucket called let's.net. Let's go ahead and open that here real quick. And what I'm going to do next is I will go ahead and upload that static content, that static logo to this particular bucket. So let's click on upload and I'm going to upload that particular file here. So let's go ahead and select the file by clicking on add files. I'll go to pictures and I'll select that logo file here and let's click on open. I'm going to upload this file and beautiful. As you can see that particular file is now available. Okay. Now, in real world scenario, you would ideally want to make this object public. One way to do so is that once you turn off your block public access here, that is you turn this off and click on save, you should be able to come back to the object. So again, let's come back to the object. You can select this and under actions, you could select the option to make it public. That's the easiest thing to do. However, I just want to show you a nice little feature that S3 has, and that's known as the concept of a pre-signed URL. A pre-signed URL allows you to make an object public for a certain duration of time, for either get operations or for put operations. In this case, I want to use it for get operations. So I know the name of my bucket, and I also know the name of my object. So we'll create a pre-signed URL for this real quick. If I now navigate to the object, and if I click on this URL on a new tab, you'll get this very nice access denied, right? Because this object is no longer public. So I need to go back to that object and I need to copy the name of the object. Now I'm going to take advantage of the AWS tools for PowerShell to create that pre-signed URL. I've logged into the PowerShell console here, and I'm going to use the AWS tools for PowerShell, the S3 module, to create a pre-signed URL for my object. Now, to verify that we have the AWS tools for S3 installed, I'm going to do a quick get module and do a list available here. If I scroll up and down, in fact, I don't see that module available here. So let's go ahead and install that module real quick. So let me clear the screen and I'll say install module aws.tools.installer. We'll first install this particular module and I'll do a verbose just to make sure that we can see the verbose output. And for the confirmation, I'm going to say $false so that we don't get any prompted for any confirmation. Now, ideally, I want to run this as an administrator. So I'm going to copy this command and we'll launch PowerShell, but this time as an administrator. So let's go ahead and navigate that and let's paste it. So it's going to go ahead, pull the AWS tools.installer module from PowerShell repository, PowerShell gallery, and I'm going to say yes to all. All right. So let's now verify that we do have that module. So I should be able to see commands called like install AWS tools module, and I can see that command resolve automatically. I'll provide the name as aws.tools.s3, and we need to do a quick cleanup as well. So let's go ahead and install that. Yes, let's accept the defaults here. That's going to pull down the AWS tools.s3 PowerShell module from PowerShell gallery. And once that is done, we should have version 4.0.5.0 installed on our system. Now, I already have the AWS credentials configured on my machine. So if I go to cd.aws, you will see that I do have that directory here. And if I do a quick ls, you should see that I have both the configuration as well as the credentials. Now, of course, I'm doing a screen recording here, so I'm not going to share my credentials, which is, of course, a bad practice. But the fact that I have my credentials configured, I should be able to run PowerShell commands like get s3 bucket, and it should resolve automatically. Pick up my credentials from the credentials file, and you can see that it displays all my buckets here in the PowerShell console. Let me clear the screen, and let's go here. In fact, let's go to our home folder. And now what I want to do is to create the pre-signed URL for that particular object. The object was the logo file, and it's inside a bucket called let's.net. So let me actually copy the object name, which is AWS train logo.png. I'm going to minimize that. And let's go ahead and create a pre-signed URL. Remember, pre-signed URL will allow us to create a time-bound URL that I can use to access that particular object. In this case, we'll say get s3 pre-signed URL. I need to specify the bucket name. The bucket name is going to be let's.net. The key is going to be the AWS train logo.png. We're interested in the get verb. I'm going to expire this, let's say in 3 days. So I'm going to say get date, and we're going to expire this in 3 days. This will create that pre-signed URL that we can use to connect to that object. I want to actually copy this to a clipboard, so I'll use the pipeline symbol here and copy this to the clipboard. Beautiful. Let me now go to the browser, open up the page, and let's paste in the URL. And you can see that now the object is available, and this object will remain available for the next 3 days. After that, if I try to connect to this object, it will say that the URL has expired. This is the beauty of using pre-signed URLs. Now, of course, for long-term purposes, if this image has to be public and for, let's say, for years and years to come, it's easy for you to just make it public. But I just wanted to talk about pre-signed URLs, and hence I use this in my demonstration here. So now that I have the URL here, I'll go back to my application and let's navigate to index.cshtml. Here in the source, I'm going to remove the default local file and paste in the URL for our S3 object, which is the pre-signed URL. Let's first navigate to let's.net configuration and test our application locally. So let me navigate to a browser and just type in localhost. Remember, our port is running on port number 80. And there we go. We see this application. And if I copy the image address, this image address is that address that we use, the pre-signed URL. Beautiful. All right, let me close all the unnecessary tabs here. And I'm going to stop my application. Let's go back to our terminal. And currently our application is running here. So I'm going to hit Control C because we need to run the application again, push the updated code to this box. Let's pull down the deploy to EC2 configuration. And I'm going to go ahead and deploy my updated application code to this particular box. It's created the publish successfully. It's updating all my files and pushing it to the EC2 instance. All right, so all the files have been successfully transferred. So let's navigate back to terminal. I'll clear my screen. And here, if I do an ls, you'll see that we have got new files. If I do an ll, you'll see the published date. Now with that thing done, let's do again a sudo .net let's code or let's .net.dll, and I'm going to hit enter. So the application again runs on port number 80. Let's navigate back to a browser, refresh this, and now if I look at this, it's refreshed my application, and this image should now point to my S3 pre-signed URL. So if I right click and if I look at the image address and I paste this in a new tab, there we go. That's our pre-signed URL. So right now, my web application is being served from an EC2 instance, and the static image is being served from an S3 bucket using the concept of a pre-signed URL. So in this demonstration, we launched an ASP.NET Core application. We deployed it to Amazon EC2 instance running Amazon Linux 2. And for the static content, we are using Amazon S3 buckets. We use pre-signed URLs to make sure that this particular static content is available for the next 3 days. I hope you found this informative, and thank you for watching.